sklearn, model selection, leave one group out. Description: Leave one group out is a cross-validation strategy that partitions the data into training and testing sets by leaving out one group at a time. It is particularly useful for scenarios where you want to ensure that data points from the same group are not split between training and testing sets, ensuring that the model's performance is evaluated based on its ability to generalize to unseen groups. Inputs: Groups: an array-like object that defines the group memberships for each data point. The length of groups must match the number of data points. Outputs: Train index: a list of indices for the training set for each split. Test index: a list of indices for the testing set for each split. Steps: The leave one group out class iterates through each unique group in the groups array. For each group, it creates a training set that includes all data points from other groups and a testing set that contains only the data points belonging to the current group. Metrics: Accuracy measures the proportion of correctly classified instances in the test set. Precision measures the proportion of correctly predicted positive instances out of all instances predicted as positive. Recall measures the proportion of correctly predicted positive instances out of all actual positive instances. F1 score: a harmonic mean of precision and recall, providing a balanced measure of the model's performance. AUC: area under the curve for binary classification. It represents the overall performance of the model, taking into account both true positive and true negative rates. Visualization plots: Confusion matrix: a visual representation of the model's classification performance, showing the number of true positives, true negatives, false positives, and false negatives. ROC curve plots the true positive rate against the false positive rate for different classification thresholds. Fine-tune parameters: None leave one group out does not have any parameters to fine-tune. Uncertainty methods: Confidence intervals estimate the range of possible values for a metric based on the distribution of results across multiple folds. Bootstrap aggregation: generate multiple models with different subsets of data to estimate a variance in model predictions. Challenges and fixes: Challenge 1: data imbalance within groups. If the groups are significantly imbalanced in terms of the target variable, the model may be biased towards the majority class in the larger groups. Sample use case: a dataset with patient data where one group has a much higher rate of a certain disease than other groups. Fixes: Oversampling and desampling adjust the class distribution within each group to balance the dataset. Weighted loss functions assign higher weights to instances from minority classes during training. Challenge: too small group sizes. If the groups are very small, the resulting test sets will also be small, which can lead to unreliable performance estimates. Sample use case: a dataset with data from different cities, where some cities have very few data points. Fixes: combine similar groups, merge small groups together if they share similar characteristics. Use other cross-validation strategies. Explore alternative strategies like k-fold cross-validation that might be more appropriate for smaller datasets.